Click the bell icon to get latest videos from Ekeeda.
Hello friends, having seen two problems on design of NPDA, let us see the third one now. This is asking us to design an NPDA which to accept the strings of the form WWR. That means basically palindromes of even length. The alphabet is A and B. Let us start with the design of NPDA first. The real problem over here is that we don't know the middle of the string. So we have to assume that every position is basically the middle. And we have a non-deterministic transition. That is, once we are assuming that it is middle, and in the other we are assuming that it is not the middle. Let us see how the design works. Taking up initial state Q0, suppose we start with the string with the A, and let's say Z is the input on the stack. We need to count it. So let us say we are pushing a 0 to remember A. This will become our first transition. That is, on an A with Z as the input symbol on that particular stack, I'll be pushing a 0. Similarly, instead of A, if I'm getting a B and Z as the input symbol on the stack, I'll push a 1. Now is the real problem. If we have 0 or 1 on the top of the stack, and we are encountering more A's and B's. Suppose the input symbol that we are encountering is A and the current input alphabet is 1. In that case, it couldn't be the middle because the symbol which was just before this was B, and hence it couldn't be the middle. We just need to put a 0. So it will be now 0, 1. Similarly, let us say B is the symbol and the top of the stack is 0. That means the past one was A. It couldn't be the middle. It will be now 1, 0. But if A is the input alphabet and 0 was the last symbol, it is possible that it is the middle. In that case, one transition would be assuming that it is the middle, and the other transition would be assuming that it is not the middle. So if we push 0, 0, it will be assuming that it is not the middle. We need to count more A's and B's. But if it is the middle, we need to pop off the 0 and go with the transition to the next state, which will be matching the 0s or 1 with respect to A's and B's to check for the palindrome. A with a 0 will be popping off that particular 0 to match it with A and going to the new state Q1. Similarly, we have one transition for B with a 1 popping it off. We will add the same transition here. B with a 1 now will be 1, 1. Once we reach state Q1, we need to just make sure that we are matching the palindromes. That means we will be constantly popping off the element by comparing it with A's and B's. On an A with a 0, pop it off. On a B with a 1, pop it off. These are the only transition after the half portion of the string. Once this is done, we will be reaching the end of the string. So the input will be epsilon and we will reach the bottom of the stack with Z. Keep it as it is. Keep it as it is. And then go to the next state. Let us say Q2. This will be a final state because it has compared the number of A's and B's with the half of the string with the next. That means it is checking the string is a palindrome or not. Having designed this machine, let us see the components of it. The components are Q, set of states, sigma, that is input alphabet, tau is a stack alphabet, delta is a transition function, Q0 is the initial state, Z is the input stack symbol at the initial stage, F is the final state. Over here we have used 3 states, so Q will have Q0, Q1 and Q2. Sigma will contain A and B, tau will have Z, 0 and 1. Let us write the transitions. Delta of Q0 on the input alphabet A with Z as the top of the stack will have a transition to Q0 itself with pushing a 0 onto the stack. Let's write the next transition. Delta with Q0 and B. Z is the top of the stack. They will have transition to Q0 only. Instead of 0, now I'll push 1. This will do the initial configurations. Delta of Q0 on A. Suppose the top of the stack is 1. It couldn't be the center. Hence we have only one transition. That is to Q0 only. We're just pushing one more 1. Similarly, repeating the last line. Q0 on an A. If 1 is the top of the stack, it will push a 0 onto the stack. It will have only one transition. Similarly, delta of Q0 on a B. If 0 is the top of the stack, it will have transition to 0 only, but pushing a 1 onto the stack. Now we will write the non-deterministic moves, that is, on encountering any, if 0 is there on the top of the stack, or on encountering a B, if 1 is there in the top of the stack. It may be possible that it is the middle. So it will have both transition, one in which it will consider that it is the middle, the other in which it will consider it is not the middle. Delta on Q0 with A as the input alphabet, 0 as the top of the stack. The first one would be to Q0 only by pushing one more 0. The other one would be to Q1. Instead of pushing, now it will pop it off. Similarly, delta of Q0 on a B with a 1. It will have two transitions. One would be to Q0 only with 1, 1. Other one would be to Q1 with popping of the 1. Let us write the last transition, that is on state Q1. Delta on Q1, if it is having A as the input alphabet, and suppose 0 is the top of the stack, because to match with the A we need a 0, simply pop it off. Similarly, one more transition, delta of Q1 with a B and 1 on the top of stack. We will have transition to Q1 only with just one pop off. With this, we have written all the transition. We have discussed Q, sigma, tau, delta. Q0 is the initial state. Z is the one which we are using over here as the base of the stack. F is the final state. Over here, we have Q2 as the final state. We left with one more transition over here. Delta of Q2 with epsilon, that is end of the string, with Z as the top of the stack. Going to the final state, Q2. We may either pop it off or we may either pop it off or we may keep the Z. Having done with all the components, now let us run one string on this machine. Let's say the string that we are taking is ABBA. We are using ID notation, that is instantaneous description. Initially the state is Q0 and the string is ABBA and the top of the stack is Z. Using turnstile notation to represent one transition, Q0 on a A with Z will go to Q0 only. Input left is BBA now. Top of the stack would be now 0Z. Once again, one more transition. Q0 having B with 0 onto the top of the stack will be pushing a 1. So it will become Q0 with a BA and the top of the stack would be now 1, 0, Z. In the next transition, we will have non-determinism. Q0 on B with 1. It will have two transition. One, keeping in mind that it is the middle. Other, keeping in mind that it is not the middle. As this is already the middle, we know we are using only one transition. It will be going to Q1 with popping off the element. So rest of the string left is A. When you pop off the first one, the top of the stack would be now 0 followed by a Z. In this configuration, from Q1, again the 0 will be popped off. New configuration would be Q1 followed by epsilon, because the string is left is epsilon now. Popping off the 0, we will have Z as the top of the stack. On this configuration, we have only one transition, that is to final state Q2, taking up epsilon, keeping Z as it is. Finally, you can see that we have reached the final state Q2 on the string ABBA. Now let us see if on B with 1 instead of Q1, if we are taking the transition Q0 only, what would happen? The current state was Q0 with BA as the input left out and 10Z as the top of the stack. Q0 on B with 1 as the top of the stack, we are considering now that it is not the middle. In that case, we will push one more 1 and stay back to Q0. Input left out would be A with the top of the stack now 1, 1, 0 followed by Z. Again, we will have a transition Q0 on the input alphabet A with 1 as the top of the stack. We will be pushing a 0. Q0 empty string with 0, 1, 1, 0 followed by Z. Now you will see the problem. We don't have a transition defined for this particular configuration. As there is no transition defined for this particular configuration, we can say that it is going to dead configuration. That means using this configuration, the string is rejected. In an NPDA, we will run all the configuration with the given string with all possible transitions, and if any one of them is leading to the final state, you can say that the string is accepted. Over here, the case 1 that we have discussed was accepting the string, and hence we can say that our language is containing the string ABBA. But this particular configuration is going to dead state, and this particular transaction is rejected. With this question, we have designed the third PDA that was accepting the palindromes over the alphabet A, B. Now in the next video, we will be seeing more questions on design of NPDA. Again, maybe based on comparisons of number of A's and B's. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.